Wow, this new experiment could prove that the multiverse exists. In other words, that our cosmos could be just one of many in an unimaginable transdimensional entity. Stay tuned to find out all about this spectacular experiment and get a multi-universal identity crisis. If you like it, I'm galactically happy about a thumbs up and a comment, because that's how we get the algorithm to show this exciting topic to even more people. Thank you guys and welcome. This universe is already beyond our comprehension, and now there are supposed to be several more? But why not, if you think about it? Because we used to think that there was only one solar system until we found out that our galaxy alone contains at least 100 billion of them. Then we realized that our galaxy, the Milky Way, is also just one of billions or, according to more recent estimates, even trillions. Galaxies, in turn, come together to form galaxy clusters. Ours is called a local group. And this, too, is just one of an untold number of such galactic clusters. This somehow suggests that our universe could also be just one of several, doesn't it? Why should it stop at the boundary of our cosmos? The past has shown that we have discovered even larger structures with better technical possibilities. Let's take a quick poll. Which of you thinks that there's a multiverse? Is our universe just one of many, or is the universe everything that exists? Feel free to write your opinion in the comments. I'm super excited to hear what you think. So far, so good. Now we know roughly what the multiverse theory says, but now we need to put some meat on the bone, as my German teacher used to say. The bone in this case is the multiverse theory. The meat is hard cosmological facts. The idea of the multiverse is closely linked to the theory of cosmic inflation, which was developed back in the 1980s. Cosmic inflation states that the universe expanded at a rapid pace in the first moments after the Big Bang. So far, so uncontroversial. However, this expansion may not have stopped everywhere at the same time. In some places it may have been irregular, allowing the formation of bubble universes. Independent regions of space with their own laws of physics. Like several soap bubbles that stick together but are independent entities. Here, by the way, you are not looking at the multiverse, but at a macro image of soap bubbles. It's really interesting how small things often resemble very large structures. But what happened to the bubble universe after it was created? The expansion between these individual smaller universes would probably have driven them away from each other relatively quickly, meaning that they couldn't normally interact with each other. But if they are close enough to each other, then they could collide before the final separation, a collision of intercosmic proportions. I wonder if insurance would still pay for such a violent crash, and the traces of this crash between the bubble universes could also have left different kinds of traces in our universe. Like a scar that was created when a bubble universe bumped into our cosmos in the early phase, and that could still be seen today. And I know what I'm talking about, because I have a pretty clear scar over my eye that I got when I ran into a lamppost while daydreaming. No joke, and I was actually completely sober. I'll have to think of a more exciting story for this one. By the way, this inflationary multiverse must be separated from the idea of the quantum multiverse. Here the idea is based on quantum mechanics and the idea that all possible outcomes of an event are realized in parallel existing universes. This is often referred to as the many-worlds interpretation. So when I bite into a muffin, nothing happens in most universes. But in a cosmos that has just been born out of quantum fluctuation, it will lead to the sudden implosion of the Earth. The advantage of the inflationary multiverse, however, would be that we can look for evidence for the cosmic scars. And there is now a spectacular new experiment by researchers at the University of Cambridge. This raises the legitimate question.
How do you study the collision of universes in the laboratory?
Like this, in this experiment, scientists are working to cool and manipulate potassium atoms to extremely low temperatures. Under these extreme conditions, tiny bubbles should spontaneously form, which can serve as a substitute for the theoretical processes that lead to the formation of universes. The hope, then, is that studying these bubbles can provide fresh clues as to how possible collisions between our universe and other universes may have left traces in astronomical data. Because under such extreme conditions, the gas behaves like a single quantum particle. But simulating the conditions of the early cosmos so accurately is of course extremely difficult. Participating researcher Zoran Hadzababic said, "It's sort of Occam's razor, which is the idea that the simplest explanation is often the most accurate, so to the extent that you can apply Occam's razor to the origin of the universe. For example, the sample with the potassium atoms has to be almost perfectly uniform for bubbles to form everywhere and cold enough to show true quantum effects that are not perturbed by thermal fluctuation. But what happens if you manage to create this so-called Einstein-Bose condensate under perfect conditions? Then comes the second step, and that is to put the condensate in a metastable vacuum state and wait for the transition to the true vacuum state by quantum tunneling. During this process, expanding bubbles of the true vacuum are formed, which may have similar characteristics to the bubble universes in cosmic inflation theory. Phew. So, if you're like me when I first read about this, you'll probably have a very specific question now. Namely, what? So here it is again in very simple terms. The researchers take tiny particles and cool them down so much that they behave like a single magic blob. Magic blob is the technical term for Einstein-Bose condensate. And then you observe what happens in this magic blob when you slowly transfer it into a vacuum. Why do they do that? Because they think it creates bubbles that could be similar to the initial form of the multiverse. That's some heavy stuff. I need some comforting bites from my muffin. The experiment is due to be carried out soon, but one thing can give us hope. Italian researchers recently carried out a similar experiment, but it was a little simpler. The conditions here were not cold enough to represent a purely random quantum mechanical process. But when they passed the sample through a tube to transfer it into a vacuum, they could indeed observe bubbles that appeared as lines in this one-dimensional setup. If this were to be confirmed in the more complex experiment at the University of Cambridge, it would be absolutely mind-boggling and a strong indication of the inflationary multiverse. Matt Johnson, theoretical physicist at the Perimeter Institute in Canada, says, "The absolute dream would be that there's something in the sky that we've observed that confirms what we predicted in this experiment. We have already detected such irregularities in the cosmic background radiation that surrounds us everywhere, which is a reflection of the moment when the cosmos became transparent." According to some researchers, potential imprint sites of other universes. So if the researchers in the lab can confirm that these irregularities could indeed be the expected imprints of bubble universes in the early multiverse, then that would probably be worthy of a Nobel Prize. I will of course keep you informed as soon as results are available, but this is only possible if he follows my channel. I'm so close to 15,000 subscribers, and I know from the YouTube statistics that over half of the viewers haven't subscribed at all. It's absolutely free. It helps me immensely, and you won't miss any more galactic videos. So guys, let's get to 15,000. Be sure to check out the video below. It's also super exciting. And if you want to support my work, please visit my Astro shop and get some great presents for Christmas. Otherwise, I would say see you in the next video. Take care, guys.